Hello everyone, welcome back. I'm Bingja. So in this video, actually it's the same day as the last video. I will be covering a few topics as you can see from the thumbnail. So yeah, let's get started. So I will start with introducing you the squares, cubes, and roots. So let's go with squares. Square is a to the power of 2, all right? So every single thing at the top right corner subscripted is called uh, a power 2. All right, so if it's a 3, then means a to the power of 3. And so on. So if it's a to the power of n, then we call it a to the power of n. All right, so squares do means this. As in the first video, I remember bringing out something called square numbers and cube numbers. So these are squares and these are cubes. All right, so we will say a squared. All right, so this is equivalent to a squared, and this is a cube. All right, and a to the power 4, power 5, and so on. All right, so oops. All right, okay, so now we'll go to root. So root is basically something like this. If you have not seen it before, this is called square root of a. All right, let's say a is an integer or a number. So this thing here is a root. So if it's by default, then it means square. So by default, right, by default, it's square root to the power of 2. So we'll call it square root. All right, if it's like this, we will call it as oh no, it lagged again. Give me a second. All right, if it's this, then we will call it cube root. Okay, this is cube root. All right, so what does root do? All right, what does root do? So from the first part, if you know squares, then let's say 3 squared is 9. All right, then root works the other way, works backwards, right? So if we say square root of 9, then it will be equals to 3, right? So if you want to know how does this work is we will square root 3 times 3. So or we will say square root 3 squared. All right, and I will need to, why does it keep lagging here? All right, and here we will say this is 3 to the power of 2 to the power of 1 over 2, right? So from here we know that square root has a power of 1 over 2. All right, it's equivalent to a to the power of 1 over 2. All right, so this is a square root, and for cube root is equals to a to the power of 1 over 3 as well. So from here we know that we will just do simple. It was equals to 3 to the power 1, which gives you 3, and it goes back to the answer. So this is how it works for a square root, and of course the same as a cube root. All right, so if you need an example here, I'll just go on easily. So it is uh, cube root of 27 is equals to cube root of 3 times 3 times 3, which is also equals to cube root of 3 to 3 cube. Then we will write it as 3 to the 3 cube to the power of 1 over 3, which at last give you 3 over 1, then 3. All right, so this is how square root and cube root works. All right, so next thing I'll talk about BODMAS, and I'll be back after I clear the canvas. So in the first part, we talked about the squares, the cubes, and the roots, and here we will do a little bit of calculations here. But before that, I will introduce to you something called as the BODMAS. You might have heard of it because it's not something very hard. So B stands for brackets. All right, so we goes like this, and O stands for order of power, which means something like a to the power square, a to the power cube, a to the power n, and so on. And D and M stands for division and multiplication. and this two can works on the same time from the left to the right. And A and S means addition and subtraction. So the meaning of BODMAS is actually to work from we give the higher order to the ones in front first. So in a list of expression, if there's bracket, we will do bracket first, followed by order of power, then division, multiplication, at last addition, subtraction. So this bring us back to the oh no okay this brings us back to the one that we talked about just now, which is squares and cubes and roots. I have a small example here. E.g. number one. I would let's work out 7 square times cube root of 8. All right, so I think it might not be too hard. So 7 square. I mean, you can just key this into your calculator, so you can get the answer easily. So it's actually 49 times 2, which gives you 98. All right, so this is how you work. So we will look at one example here to apply your BODMAS skill. So from here, from BODMAS, we have a bracket here. So we are supposed to do what's inside the bracket first. So 6 times 5 square plus 3. All right, so according to BODMAS, after B, we will look for O. So O here is 5 squared, so it's 6 times 25 plus 3. All right, then we will further continue down to D and M. D and M, so we have multiplication here. So we have 25 times 6, which gives you 150. So 150 plus 3, and lastly A and S. So you get 155 inside the bracket. Okay, so after you have done this, you can list out the everything here minus 4. So it's purely A and S, so you can just key it in your calculator, so you will get the answer as 156. All right. So yeah, this is just a little bit of example of BODMAS, and you just need to take note of that. So because it's very important, because if you don't follow the BODMAS, you will get a little bit of different answer. Like for example, when I was like very young, and one of my friends actually asked me what is 1 plus 1 times 0. All right, so I'm a guy who like to do quick math, so I just straight answered 0 because I saw 0, right? But it's wrong because BODMAS says we need to do multiplication first, only addition. So it will give you 1 equals to 0, then it's equals to 1, which gives you 1 plus 1 times 0 is equals to 1. So yeah, this is the importance of BODMAS. And by the way, I need to cross here first, just in case someone screenshot this and say I'm teaching the wrong thing. So yeah, so this is basically the importance of BODMAS. So yeah, let me check how many space I still have here. Okay, quite a lot. So I'll continue with our next part of today, recurring decimals. All right, I think I need to clear the canvas here. Okay, so here in this part, I will talk about recurring decimal, right? So recurring decimal is a very important subtopic that you will need to take note of, because this is a little bit tricky if you don't know how to do it. So what is a recurring decimal? Recurring decimal is like, let's say for example, 0.77777777, and it goes all the way to a long more. But take note that it can only be called a recurring decimal if and only if, uh, let me erase this ugly thing here. Oh no, this cannot be erased. All right. If and only if it's the same repetition. All right. So there are different types of way that you can denote a recurring decimal. For example, we can say 0.7 dot. All right. This is the first type to denote a recurring decimal. All right. This is equals to the same meaning, and this is 0.7 bar. All right, so you can denote it with the dot or a bar. All right, so other things to actually take note of is, let's say you are repeating 748, 748, 748, and so on. So 748 is a set of repetition. So how do you write it? You can write it in two ways actually. So the first one is 0.748 and you put a bar above 748. This is the first type you can write. And the second type is the dot type, where you put the dot on top of the first and the last. All right. So this is how you denote the same thing. All right. So we will usually in exams, what's special about this subtopic is they will ask you to convert a recurring decimal to fraction. All right. So you can't possibly key it in the calculator, so it's gonna take a long time. Or so there's a way to convert recurring decimal to fraction, and I'm going to show you. So here, let's give an example. Convert 0.777 dot. All right, convert to fraction. So how do you do it? So there are a few steps. All right. So step number one, you let x is just an unknown, equals to 0.777 dot. All right. Then since all is the same, you can just make it let 10x. All right. If it's 10x, we will just straightly multiply this by 10, so it's equal to 7.777 dot. All right. So it's actually the same because the 7 goes on forever. So the next thing is step 2. Minus 2 of them. 10x minus x is equals to 7.777 dot minus 0.777 dot. All right, so this gives you 9x is equals to 7 because we will cancel out the back part. All right, and x will finally give you 7 over 9. And therefore, from the beginning, you have denoted x as 0.777 dot is equals to 7 over 9. All right, so this is how you do a recurring decimal convert to fraction, and I'm going to show you two more examples because okay, I'm going to show you two more examples on how to convert recurring decimals to fraction. So example 2, convert 0.748 to fraction. All right, so if you would like to try, please do pause this video and try and only resume back when you have finished. So I'll just start with it. Step 1, we will let x equals to 0.748748 bar. All right, and you will need to multiply x with the amount of decimal places which is the same. For example, 748 takes in thousands, right? So we will get 1000x instead to be 748.748748 bar. All right, makes sense? Okay, so the step 2, we will minus 2 of them. 1000x minus x is equals to 748, and therefore you get 999. X is equals to 748, and at last x is equals to this. If you want to check whether you can simplify it, you can always go to your calculator and check it. All right, this is the final form. You cannot be simplified anymore. So this is the second example. Hope you get the correct answer. And last, I will go to the third one, e.g. number 3. All right, so in this part, I will like you to convert, do I have example here? Okay, convert 0.3747474 dot dot, all right, to fraction. Take note that this is a little bit different from the previous one, and we will see. So pause this video and try it out before you continue. Okay, so same thing, let x equals to the original one, 747474 dot dot. All right, but now as you can see, 3 is not in the repetition. So you will need to exclude it first. So how do you make 3.7774 something? So you multiply x by 10. All right, 3.747474. All right, makes sense? So from here you cannot just subtract two of them because you can't get rid of the 74 recurring part. So from here you will need a further two more decimal places of multiplication. So which gives you 1000x is equals to, okay, 1000 goes to 3, so it's 374.747474, and it goes on. All right, so from here we can get rid of the 7474 part because you see both of them are the same, right? It's the same here. So we will instead subtract 1000x with 10x, okay, and this will give you 371. And at last you will see it's 990x is equals to 371. Therefore x is 371 over 990. And if you would like to make conclusion, you can say that 0.37474 is equals to 371 over 990, and this is the answer. So yeah, this is the recurring decimal part. It's a little bit tricky, but it's not too hard if you do a lot of practice. And yeah, I think I would touch on a little bit on how to convert fraction. All right, convert fraction back to a recurring decimal. All right, let's say from the first part, from the first example, we have why does this move actually? All right, from the first part we have an example of 7 over 9. All right, so I will do an example of 7 over 9. So you are to convert 7 over 9 to decimals. How do you do that? So we know that this is a division notation, so we have 7 divided by 9. And if you have do this before, you can probably know how to continue here. So first thing first, 7 cannot be divided by 9 because 9 is larger than 7, so it's 0 point. So it's 0 and it's 7, 0 and it's 7. 9 times 7 is 63, and it goes on forever. So from here you can actually conclude that it goes on the same, and therefore you can know that it's 0.777, and it goes on forever. All right, so this is how you convert a fraction back to a recurring decimal, and you can try it for example 2 and 3. If you have any questions or you are stuck in anywhere, feel free to private message me in the Instagram. All right, so yeah, I think for today, for this video I will just stop right here. Just before I stop, according to the syllabus, I will have to tell you guys about notation. So this is equals. So I'll just write here first, just in case you don't know. This is not equals. All right, this is lesser than. All right, and this is lesser or equal to, and this is more than, and this is more or equal to. Wait, let's not talk about more. We will say larger than. All right, larger than and larger or equal to. All right, so yeah, for this I will end this video right here. Thank you for watching. I hope this will help you. See you guys next time.